So we're back again for the, let's see, we're at the August 2015 exam, starting with the 2-point open response questions, number 25. All right, so you have a cube. What that simply means when they say it's a cube is that if you have a length of 6, you have a width of 6 and a height of 6 as well. So let's see, density, mass, okay. What we do with density, okay, it's in science, it's mass over volume. In math, we kind of have stuff over space. I know that's pretty weird to use those words, but that sums it up because there could be a lot of different versions other than just mass and volume. The stuff that we have is actually the mass, so that'll go on top. And then the space will be the volume. So let's get the volume of a cube. The formula is going to tell us base times height, but that B, got to remember that that's the area of the base. So for a prism, what you have is, in this case, a square base, 6 by 6, and then a height of 6. So I believe that's 216, and that's going to be cubic centimeters. And our density is in grams per cubic centimeter. So we're going to be all set here. We don't have to change any units of measure or anything like that. So we'll go back to density. And what it is, it's going to be the mass of 137.8 grams divided by the space. What was it? Okay, 216 cubic centimeters. And when we divide that, we'll get our number of 0.63, 7963. And what we're going to do now is we're going to look which of these is the closest to that. It's going to be right here. So our answer is going to be ash. And for 2 points, this is plenty of work over here. Okay, make sure you answer the question though. Don't just stop at what the density is. All right, moving on to the equilateral triangle, inscribed. There's at least 3 ways to do this problem. So I'm going to show you the way I do it. I construct a regular hexagon. And the reason I do that is because it covers 2 of the standards that we have to teach. It covers equilateral triangle. It's probably not the best, but it covers it. And it covers constructing a hexagon. So I'm going to go over to Geometry Sketchpad to do this because I just can't show my compass tool here. So what I've done is I have created that circle that you saw over there. Now what I'm going to do is I'm going to pick any random point that I want on this circle. Okay. Now what I'm going to do is my compass tool, the center of it's going to go right there. Rather than on T, it's going to go right there. Now what I'm also going to do is I'm going to find the radius that hits point T from here. So we've got that. It happens to be this size. So I'm going to construct that circle. Now, you don't have to construct the entire circle. You just have to have the arc that hits right here. Now, this just created a new point right there. Okay, again, this is just one way of doing this problem. There's a lot of ways that work, but this is how I do it. So now I'm going to put my compass tool here, and I'm going to, again, use that same radius to pass through T. So we do it again. Now, it's going to start getting a little confusing here. This is the original. Let me darken that for you. Get it a different color. So that's the original. Now, this is just your work. I can't erase these, but I can make them dashed. Okay? So you can see. Now, I do want to note those are the points. Now, we've just hit 3 points on here. These 3 points are going to be equally spaced. Okay. Now we're going to put the center of the compass tool here. Again, we're going to open up to that, construct that circle. I picked up a 4th point right there. Same thing. Construct a circle, center there, and here's our last one. Construct that one. And yeah, it does hit right there. So what we just found was, let me get that back to, hard to see the points, so back to thin. Okay, so now what we have is our 6 equally spaced points. Now that would be what we need for a hexagon. Well, why did I do that? Because for an equilateral triangle, all I got to do is pick every other one and construct the segments. So these 3 points, if I let it label those, let's see, label points, sure, we'll call it B, C, D, F. And that's what we have right there. So that'll cover 2 constructions that we could possibly do. Again, there's a number of other ways to complete this construction. If your teachers show you something different, don't like this, fine. All right, now let's go to, where am I at? Back over here. Okay, so that's how I did the equilateral triangle. All right. The next question kind of is, why did that work? Well, let's try to remember where we were at, right? So if we had these 6 equally spaced dots, it's constructed the way that I had it, right? Okay. When you construct center here, radius here, right? What you just did was all 3 of these are the same. So that is a 60-degree angle. Well, that central angle is equivalent, or the same measure, I should say, not equivalent. It's the same measure as this intercepted arc. So if you space out 60 degrees between all of them, that gives you 360. And again, if we do every other one, right? So now you're going to have your equilateral triangle. They're all going to be 60 degrees. And we have what we needed. All right, let's move on. Okay, looks like it's going to be pretty straightforward here. Probably similar triangles, proportional sides. Oh, yes, they gave this. What I was looking for was kind of a reason to have similar triangles. If these 2 angles are the same, okay, so basically angle ADE congruent to angle ABC. That's one pair of angles, corresponding angles congruent. Angle A is congruent to itself, so we have similar triangles. Okay, by that angle similarity postulate. All right, let's see. Determine and state the distance from B to C. All right, so this is what we need. Here's the trick in this problem. You want sides that are proportional, but what you have is the 230 is not proportional to the 85. It's 230. It's going to be proportional to whatever 230 plus 85 is. What's that, 315? Okay, so you have to calculate that. The whole side is 315. Okay, now the 120 should be on the top of the other fraction and x underneath. Okay, this is one way to do this problem. Corresponding sides of similar triangles are proportional. So let's get the cross products. Okay, and what's 315 times 120? That would be 37. Let me just show that work. That would be 37800 divided by 230, and I get approximately 164.348. Let's check units of measure. It wants yards. These are in yards. All right, no tricks there, so we're good. So about 164 yards to go from B to C. Okay. Parallelogram. Okay, it tells us that we have a parallelogram we have to prove ACD. We have to prove this angle. We're going to prove that angle is the same as that one. And they're telling us that it's a parallelogram. All right, that should be pretty easy to do. So what I'll start with first, ABCD is a parallelogram because it's given. Now, basically the question here is, do you know which pair of opposite sides need to be parallel for us to use alternate interior angles theorem? What I try to teach my students is look for the N or the backwards N or Z, backwards Z, and these inside angles, these inside corners, if you have that, these are your alternate interior angles, so then those are your parallel sides. To play it safe, you give us both pairs of opposite sides parallel, but to know what you really know what you're doing, okay, you should specify these two. So I should say DC is parallel to AB. I'll give a reason. It's because opposite sides of a parallelogram are parallel. And now because of that, we get angle ACD congruent to angle CAB. And that's because alternate interior angles theorem. I'll write that out in case your teacher doesn't like you using that. So because alternate interior angles are congruent when parallel lines are cut by a transversal. So that's kind of, the explanation of what alternate interior angles theorem is. All right, another similarity problem. Okay. Usually it's angle-angle similarity postulate, but they're given us side lengths. That's kind of an indicator we're going to probably use potentially side angle side. Yeah, probably side angle side because they do give us a pair of angles. So that's what I'm thinking. Let's just, we got to get the corresponding sides. So RS should be corresponding to XY. Okay. And so let's check out what is 6 over 9. And ST is 14. That should correspond to YZ. Yes, they do give us YZ, 21. All right. Now, let's see first, does 6 over 9 in fact equal 14 over 21? And all we got to do is test the cross products. Whoops, it's a question mark actually. Is 6 times 21 equal to 9 times 14? That's 126. Yep, it is. Okay, so the cross products are equal. That means these numbers are proportional. Okay, now we've got to go through the process here. So what I would say first is 6 over 9 does equal 14 over 21 because their cross products are equal. That's one way to go. You could also reduce them. You could make them 2/3, and you could show the work for that. I'll say this, 6 times 21, right? That's one cross product is 126, and 9 times 14 is 126. So that's kind of your reason right there. All right, so that gets us really both the S's here. Kind of keep track of what we're doing. Now, what we need is the included angles congruent. And that is what they give us. So angle S is congruent to angle Y. That's because it's given. And now we actually can finish the proof right now. Triangle RST is similar to triangle XYZ because of the side angle side triangle similarity, either theorem or postulate, whatever your teacher uses. Okay, good enough for 2 points. Again, this work up here is kind of key. Show that scrap work and then go ahead and do your explanation. Justify doesn't mean necessarily you need to do a proof. I just chose to. All right, so number 30 here. Properties of rigid motions. Okay, basically what you're looking at is if you can map one figure to another using rigid motion transformations, that's essentially what they're looking at right there. Okay, so what we want to do is find a sequence of rigid motion transformations that will map ABC onto XYZ. Now to me, it looks like a 180-degree rotation, and it is. And the center of that appears to be the origin. Okay, so let's do that. Yeah, that's definitely going to be the one. So let's try this. We're going to rotate triangle ABC centered at the origin by an angle of 180 degrees. This will map triangle ABC onto triangle XYZ. Okay, so that's going to be step one. Now, that is not enough by itself. Okay, you did find the rigid motion transformation that would map one onto the other. Now we've got to explain why that means they're congruent. Okay, so the second portion of this would be since a sequence of rigid motion transformations what does that mean? Rigid motion transformations, it means transformations where the image and pre-image are congruent. So make sure you kind of understand that, express that, you know that. Since a sequence of rigid motion transformations could be used to map triangle ABC onto triangle XYZ, the figures triangle ABC must be congruent to triangle XYZ. And that's basically it. The only ones that won't are dilations or stretches. And you might want to note this, a rotation is just to be safe, a rigid motion transformation. All right. Next, okay, lovely. So what they did here was, usually I like to graph these, but they mess with us a little bit here. Okay, how do they mess with us? They gave us coordinates that would be off the graph, unless you kind of adjusted, your scale or whatever. I guess you could. Yeah. So I guess I'm going to have to sketch this and just give estimates. Sorry, that was awful. 1,4 is going to be approximately there. Okay, 16, 14. Somewhere up here. All right, so that's approximately where F is. Okay. Now, partition a segment. You're trying to cut the segment into the number of equal parts that you need, and then find the location of maybe all the points. Let's do that. So partition a segment. Let's understand a ratio of 2 to 3 means we want to make 5 equal parts. Okay. Now, what I like to do is, on a graph is better, but we can do it here. I like to consider the change in x and the change in y. All right, the change in x is from D to F, from 1 to 16. That's going to be 15 steps. So the change in x right now is 15. And that's from D to F. D to F. Change in x is 15. Now, okay, if I want 5 equal parts for that, so each part for the change in x will be 15 over 5. Run out of room here. So each move will be 3. Okay. The change in y, let's go, what's this? 4 to 14 is 10. So that's going to be 10. Again, 5 equal parts, right? So each part for the change in y will be 10 over 5, which is 2. So what I'm going to do for this is I'm going to kind of list all the points that I could face here. So from D to F, right? D is at 1, 4. If I move, let's go right 3 up 2 from there, that's going to be what? 4, 6. Right 3 up 2 again is going to be 7, 8. Right? Right 3 up 2. Do it again. Okay. Right 3 up 2 is 10, 10. How many points is that? That's 4. So then hopefully our last one is, no, that's not going to work. Oh, there's 1, 2, 3, 4. I got to do 2 more. I got to find this location. Right 3 up 2 is 13, 12. And hopefully for our last one, we land at F. Right 3 up 2 does take us to 16, 14. So that does work. Now we got to find D to E is a 2 to 3 ratio. How about this one? This would make it 2 parts to 1, 2, 3 parts. So E is right there at 7, 8. Okay. Tricky problem, but we can manage that one. All right, next one is a trig problem. And I believe this is a 4-pointer. We're going to have to use double trig, looks like. Let's see. We won't have to use law of sines to do this. Okay. No, we won't need law of sines. So that'll be great. What I'll probably do is let's get this distance from here to here, right? That should be reasonable. We'll call that x. We can get the distance from here to here, which is y, and then we'll subtract. So that'll be good. Now, what I like to do, if showing students this, is separate the diagrams. Let's look at the small right triangle first. Okay, so we got 125 in x and 16 degrees. So this kind of indicates a trig, right triangle trig. It's not going to have to be law of sines, so we're good. Compared to the acute angle, that leg is opposite, this leg is adjacent, and of course, this is not a leg, this is the hypotenuse. Stop at the right angle. Now, the two sides that I want to work with are opposite and adjacent, so I'm going to pick tangent. Now, tangent of our angle measure is going to equal whatever side is the opposite to the adjacent. Call it x, right? Now, just go ahead and type in whatever tangent of 16 degrees is, and make sure you're in degree mode, not radians. What I get is 0.2867 something. Now, I always put that over 1, because trig, I try to teach students trig is a ratio of two sides. They gave us just one number, so put it as a ratio. Put it over 1. Okay? And just bring that back down. And what we're going to do is cross multiply. So 0.2867, whatever, x equals 125 times 1. And we're going to divide by that. Now, try to be accurate. You're not supposed to round to the last step. Okay, so hit the 125 and then go back up in your calculator if you have the Inspire. Grab whatever that is in the calculator, okay, and then hit enter. And you get approximately, and I'm not going to round, okay, I get 435.927. All right, so that's step one. Now I got to go get y. And what I'm going to do is I'm going to create a whole new, create another triangle. Okay, I'm going to just focus on this big triangle. Okay, and this time it's still got the 125, right? But it's got a 7-degree angle now. Okay, same deal. This is the hypotenuse. This is the adjacent leg. This is the opposite leg. We're going to use, we're going to use tangent again. It looks like opposite adjacent. Yeah. So we got tangent of the angle should equal 125 over y. Now your tangent of 7 degrees got a little smaller, 0.12278. So I'll round it, but remember, don't round it in your calculator. Okay. When we cross multiply, we get that mess, and we're going to divide. Okay. So now y is going to equal. Let's keep it right there. Y is going to be approximately 1018.04. All right, now remember we want to come back here. We want to get a to d. So a to d is going to be subtract those two. 101.1804 minus the 435.927. And AD is going to be, I get 582.116. Okay, that's AD. And what did it say? Nearest foot. All right, and this is all feet. I better double check that. Yeah, it looks like it's all feet. So, okay. So AD is approximately 582 feet. There you go. That's it for this session. I'm going to put the other ones on the next video. Thanks.